an equation here. And the ones that, if you did the homework last night, the ones you guys had last night, let me get a different color. I don't want blue. Okay, the ones you did last night were something like this: square root of x plus 3 equals 5. You squared both sides. You got x plus 3 equals 25. You subtracted 3. The answer was 22. Right? So that one is a really simple version of what you had to do. Some of them were a little more complicated. But in general, you got it to where you could square both sides, and you squared both sides and solved. The problem with this particular equation is that I need to get rid of this square root, but all the other problems you guys did last night had a number right here. So you could just square it, and it was very simple to do. But 5 plus 2x is not a number. So this is going to be a little bit more involved to do this problem. Also, this 2x, I cannot do something like minus 2x and move this over here, because this 2x is not underneath the square root, and this one is underneath the square root. So I cannot move them from side to side. That would be incorrect. So erase that there. So this is what we have to do on a problem like this. We are still going to square both sides to get rid of that square root. But when we square 5 plus 2x, we cannot just say 25 plus 4x squared. Okay? This is 5 plus 2x times 5 plus 2x. And so over here, it just cancels the square root. We just have x squared minus 2x plus 1. Now, it is best if you can do this next part that I'm going to do in your head. Like I would automatically look at 5 plus 2x squared, and I could tell you it's 25 plus 20x plus 4x squared. Okay. The reason being, you're going to do 5 times 5. That'll give you 25. 5 times 2x is 10x. 2x times 5 is 10x. And 2x times 2x is 4x squared. And then, so that is 25 plus 20x plus 4x squared. Okay, so to do that in your head, you do what different teachers will tell you different tricks. I call it square, double square. You square the first. 5 squared is 25. Then you multiply these two together. 5 times 2x is 10x, and double it. 10x times 2 is 20x, and then square the last. 2x squared is 4x squared. So it is best if at this point in your mathematical career that you can do that part in your head. So I would have skipped from right here all the way down to this section right here. However, I would rather you be slow than wrong. So if you need to write that out each time, go ahead. But if you can do it in your head, that's even better. Okay. All right, questions so far? All right, we have a quadratic. With quadratics, we will move everything to one side so we can solve. So we'll subtract our x squared. We'll add the 2x. And we'll subtract the 1. So that is going to give us 3x squared plus 22x plus 24 equals 0. And I'm going to get out my key to this because I can't remember if that factors or not. It does. So if you're not sure if it factors and you don't want to waste your time trying to factor, you could always use quadratic formula here. I am going to factor because this one does factor. There's no really good way of telling if something factors or not, except for just trying to factor it. So that's why sometimes I will jump to quadratic formula if it just looks hard. But this one will factor. For 24, you could do 2 and 12. 3 and 8, 1 and 24, 4 and 6. That's it. So we want to get 22. These are a lot harder to factor than the more simple ones. Let's see. 8 and 4 and 6. 4 and 6 is going to work. So if we put our 6 right here, that means we'd have to do 3 times 6, which would give us 18x. And if we put our 4 here, that's going to give us 4x. And if you add those two together, you get 22x, which is what you're supposed to have in the middle. So this factors into 3x plus 4 and x plus 6. So that means 3x plus 4 equals 0. So 3x equals negative 4. Divide by your 3. X equals negative 4 over 3. And over here you'll get x plus 6 equals 0. So that's just x equals negative 6. Now, this, if you didn't have a chance to watch the video, but with radical equations, you always have to check for extraneous solutions. Okay, so some of the worksheets you guys were working on for the rational equations asked for extraneous solutions. That was just looking for those excluded values. Okay, with radical equations, they show up a little bit differently. When you square both sides, there is a possibility you created an answer that does not actually work in the original problem. It is really important that you always check your answers for these because extraneous solutions are very common for these. With the rationals, you might have an excluded value you should have thrown out, but it's fairly rare. It's not going to happen that much. It happens a lot with these radical equations. So if we get the calculator, I'm going to let you guys use the calculator. I don't always, but I think I will. Let's see, it's the wrong thing there. Calculator. I'm also going to show you a trick here. It makes it a little bit quicker. Not that much, but a little bit quicker. So our equation is 5 plus 2x and the square root of x squared minus 2x plus 1. So, well, there's a couple ways you could do this quickest. Let's do it this way. So, our answers are negative 4/3 and 6. Sometimes it's kind of hard to type in that negative 4/3 because it's got to be in parentheses and everything. So, one thing you can do is you can store negative 4/3 as a variable in your calculator. So if we just do negative 4 divided by 3, and right above your own button, there's a STO button with an arrow. Have you guys used that before? Usually students have not. So if you put the STO with the arrow, it's going to put a little arrow here, and then you can store it as a variable. It's okay to store it as x on these calculators. It'll be fine. However, when you get to calculus and you have the TI-89s, you don't want to store something as x. So let's just store it as a, but you could use any letter. A, B, you could use x if you wanted. So then, since it's stored, anytime I type a now, the calculator actually thinks that a is negative 1.3 repeating or negative 4/3. So if I want to check if these two are the same, I could do 5 plus 2a, and I get this number. And then I could do the square root. Square root of a squared minus 2a plus 1. And I get 2.3 repeating. So this works because you get the same number on both sides when you plug it in. Okay. Another thing that's good about this, doing it this way, if now what I could do is I could store negative 6. Alright, let's do negative 6. I could store it as my A. And if you have if you press second enter, it'll bring up the last thing you typed in. If you press second enter again, it'll bring up the one before that. If you press second enter again, it'll bring up the one before that. So there's 5 plus 2A. You don't even have to type it in. And then you can do that same thing. Okay, and see here, when I plug in negative 6, I get to the left side, I get negative 7. When I plug in negative 6 over here, I get positive 7. So negative 6 is not an answer for this one. Now, you do not have to do all of that stuff with storing your values if you don't like it. You could very well have just said 5 plus 2 times negative 6, and then you could do the square root of negative 6 squared minus 2 times negative 6 plus 1. And you can see you get the same values there. So you don't have to store your values. I just wanted to show you that, guys, because some students find it a little bit quicker. And it is helpful if you have a bad number. If you have a big decimal or something that is going to be really cumbersome to plug in, it makes it a little bit quicker there. So use it if you would like. But 6 is not actually an answer, so we have to throw that out. And so negative 4/3 is our only answer. Okay, questions? Okay, with these problems, if you get 2 answers, I'd say about at least 50% of the time, one of them is extraneous. Maybe a little more often than that for the problems that you'll see in this class. If you get 1 answer, sometimes it's still extraneous, and then it would be no solution if that's the case. Now, if you go to do these problems and you're getting like most of your answers to be extraneous, so you get no solution for number 1, no solution for number 2, no solution for number 3, because all your answers end up being extraneous, you're probably not doing the problem right. You're probably solving it incorrectly, so the answers you plug in do not work. So you won't see it on every problem, but you'll see it very frequently. So you do have to check your work on these. If you don't, you'll end up with a lot of answers that aren't really answers. Let's see, that one is on the notes. So is that one. All right, let's do this one. I love these problems. Some of you guys will think that I'm crazy for loving these problems. Some of you guys will be math nerds who also love these problems. I love a long, complicated problem where you get the right answer at the end. It's just so satisfying to me. Now, I know that none of you guys are going to have a job that you work at where you've got to where your boss hands you this problem and says, solve it for me, please, by hand. You can take a picture of this on your phone and probably get the answer in an app really quickly. So I know you don't have to necessarily be able to do this for a job, but there's a lot of logic that goes into this, and that logic is good for your brain. It's good for your ability to set things up, all kinds of things like that, even if there's other ways of doing this where you don't have to know how to do it. So I love these problems because it's almost like a puzzle that you're figuring out. Some of you guys may think I'm crazy and hate this type of problem once we're done with them. These get pretty lengthy here, so you want some room for this one. This one is difficult because you need to square both sides to get rid of the square root. But you also have this 1 out here that is not underneath the square root. So when you can't put that 1 into either one of these square roots, so you're going to have to square both sides like this. And so over here on the left-hand side, it's very simple. A square and a square root are inverses. You just end up with 6x plus 12. But over here, look at the mess that happens. I cannot just square 1 and square 4x plus 9. I've got to write this as 1 plus the square root of 4x plus 9 times 1 plus the square root of 4x plus 9. And then to multiply those together, I've got to distribute here. I've got to FOIL those out. So I'll have 1 times 1 will give me 1. 1 times the square root of 4x plus 9 is going to be, I'm going to write the 1 here. You don't have to. In fact, you probably shouldn't. But I think it just makes something a little more clear in the next step, so I'm going to put it there. And then we'll have, for the inner terms, we get 1 times the square root of 4x plus 9. And for the last terms, when I do square root of 4x plus 9 times the square root of 4x plus 9, that is like saying the square root of 4x plus 9 squared. And what is the square root of 4x plus 9 squared? It's just 4x plus 9, because the square root and the square undo each other. So when you multiply the square root of something times the square root of something, you just get whatever's on the inside, so 4x plus 9. All of this equals 6x plus 12. And so you look at this and think, oh, Miss Hyatt has made this worse instead of better, right? It looks awful. And it is pretty awful. But we're getting a little bit better, even though it doesn't look like it. So I can simplify this stuff over here a little bit. I have a few things I can combine. So I could put this 1 and this 9 together, so I'd get 10. I'm going to write that 4x up here. You put the n, doesn't matter. And then if I've got 1 square root of 4x plus 9 plus 1 square root of 4x plus 9, I can add those together. It's kind of like having 1x plus 1x, which would give you 2x. So you're going to get 2 square root of 4x plus 9. Now, it still doesn't really look any better. But the good thing about this is I don't have square roots on both sides of the equation now. I've only got square roots on one side. So what I want to do is I want to try to get that square root over here by itself so that I can square both sides. So I'm going to get rid of this 10. I'm going to subtract that 10. I'm also going to subtract this 4x and move it to the other side. So that gives me 2x plus 2 equals 2 times the square root of 4x plus 9. And then I could square it as it is right now, but both of these numbers over here are divisible by 2, so I'm just going to divide off that 2. It's multiplied by that square root right there, so this is going to be x plus 1 equals the square root of 4x plus 9. So we've now got this problem down. It does look a little bit better now. It's a little less scary now. But we've only got this down, now we've only got this problem down far enough to be as easy as the last problem that we did. Right, so we've still got a lot of work to do here. So now that the square root is by itself, I'm going to square both sides. But be really careful there when you're squaring this. X plus 1 squared, that is not x squared plus 1. It is x squared plus 2x plus 1. You've got to square, double square, or if you need to, write it out, x plus 1 times x plus 1. So you have x squared plus x plus x plus 1, which would be x squared plus 2x plus 1. And that will equal, this side is easier, you just get 4x plus 9. Okay, questions? All right, and sometimes students can do all of this correctly and they get to the end and then they have trouble. So if you get down here, you're now in Math 1 again. This is a problem a Math 1 student could solve. So if we have a quadratic, what do we have to do? Okay, probably factor. It might have to be quadratic formula, but before we can factor, we have to everything on one side. So I'm going to minus that 4x and subtract that 9. And so I'm going to move over here. So x squared minus 2x minus 8 equals 0. And this one will factor. So you could do x minus 4 times x plus 2 equals 0. And so you get x equals 4 as an answer and x equals negative 2 as an answer. For these, you must always, always, always check your answers because there's a good chance that one of these does not work. So I will let you guys use your calculator. Let's see. I can see mine. So for the problem, you would do square root of 6 times 4 plus 12, and you would get 6, and then you would also do 1 plus the square root of 4 times 4 plus 9, and you also get 6. So 4 is the correct answer. That time I did not store my value. You don't have to. If I wanted to store the value, I'm just going to, for the fun of it here, negative 2, store a. So if I did the square root of a, 6a, 6a plus 12, I would get 0. If I do 1 plus the square root of 4, square root of 4a plus 9, I get 2. 0 does not equal 2. So negative 2 is not an answer. Four is your answer there. Okay, questions so far? Now, whenever you do your homework tonight, whenever you get done with it, you need to go take it to your parents and you need to show them this work just to impress them. Because these problems get really long and scary looking. Sometimes I'll have you guys do them up on the board and I like to leave them up for Math 1 to see because they always like go into a panic if they think that's what we're going to have to do that day or something. Because this stuff gets really extensive, really long. I love these problems because they're kind of difficult, but if you get the answer at the end, you feel so accomplished. Don't get the answer at the end, maybe you just are mad though. So, but you can go show your parents. They're going to say, oh, my baby's so smart. Look at what they can do. Because I would say there's probably not too many of your parents that can still solve this equation right here. If they ever could. There might be a few of you. Maybe a few of you. Every once in a while I have some. But typically, there's a lot of parents that never even took pre-calculus because it wasn't required. It's still not required for graduation. You don't have to have this class for graduation. You could take AFM instead. And then there's, just a lot of parents who've forgotten it. So go home and impress your mamas with this here. They won't even know if the answer is right, so they'll still be impressed with their sweet baby that's so smart. Okay, here's our next one. So, for this problem, we got 3 equals the square root of 4 minus r plus the square root of r plus 1. So, I'm going to do something here. Don't write it down because there's a better way. Okay? So, I'm just going to show you what type of problem you run into if you just square both sides from the beginning right here. So don't write this down because I'm going to show you a better way, and that's the one I want you to write down. So you could square both sides. Over here, that'd be great. You just get 9, right? Over here, though, it does not get rid of it would not be 4 minus r plus 1. You would have to write square root of 4 minus r plus the square root of r plus 1 times the square root of 4 minus r plus the square root of r minus 1. And then you would have to distribute. So here you get 4 minus r, but here you would get the square root of 4 minus r times r minus 1. And here you would get the same thing again, square root of 4 minus r times r plus 1 plus r minus 1 for that last, or let's see, that should have been a plus right there, plus 1. And so you got all this stuff. You got to multiply this stuff in here. You got a quadratic underneath your square root. You still have to move things over to the other side. You can do it this way, but it's just a little bit more difficult if both of your square roots are on the same side, in my opinion, anyway. So, instead, I'm going to erase this. It doesn't make it much easier, but it does make it a little bit easier. Let's do this. Oh, let's not do that. Okay. Let's move one of these over to the other side. So I'm just going to subtract my r plus 1 here, square root of r plus 1. And so I'm going to write this as 3 minus the square root of r plus 1 equals the square root of 4 minus r. This is still a difficult problem, but by doing that, now when I square this side, I at least do not have 2 square roots that I'm having to deal with. And then over here, the square root will cancel out the square. So this is 3 minus the square root of r plus 1 and 3 minus the square root of r plus 1. We have to multiply it twice. If you can do it in your head, do it, but it's a little harder to do in your head. So if you distribute, 3 times 3 is 9. Then you're going to do 3 times the square root of r plus 1. So that's going to give you minus 3 square root of r plus 1. Here you get another minus 3 square root of r plus 1. And then for the last, you'll get plus r plus 1. Okay, questions? Okay, then we're going to combine some similar terms, or like terms. So 9 and 1 is 10. Put those together. I'm just going to put the plus r up here. And I've got a negative 3 square root of r plus 1 and a negative 3 square root of r plus 1. So I can put those together and make that 6 square root of r plus 1. Okay, so let's move everything that's not under that square root over to the other side. So I'm going to subtract the 10 and subtract the r. So I get negative 6 square root of r plus 1 equals negative 6 minus 2r. Now, on the last problem, if we look back there, at that level right there, I divided by the number that was in front of my square root. But it did go evenly, which made that nice, right? If I do that here, if I divide by negative 6, that'll be good right here, but it means I'll get a 1/3 right here, so I have a fraction to deal with. So, depending on your love of or hatred of fractions, you may choose how to proceed. You could divide both of these by negative 6. Okay, if you do, you're going to get 1 plus 1/3 r. Okay? So, I think I'll just do it both ways. So, let's see. If you divide by -6, you get square root of r plus 1 equals 1 plus 1/3 r. So, if you do it this way, you're going to then have to square both sides. And so you got r plus 1 equals, and here you got a square, double, square. So square the first, 1 squared is 1. And then double, so you multiply these two together, 1 times 1/3 r is just 1/3 r. And you would double it, which would give you 2/3 r. And then you would square the last. So 1/3 times 1/3 is 1/9 r squared. Now, I really don't want to have to factor or do quadratic formula with a fraction in the quadratic formula or factoring, because that would be painful. So, what you could do here, if you look, we could do like we did with our rational equations. If you look here, you've got a denominator of 1, 1, and 1 for all these. You got 3 here, you got 9 here. All right. So what would the common denominator of those be? 9. So if you multiply everything by 9, all the terms by 9, then that gets you common denominators so that this goes away. So you would have 9r plus 9 equals 9 plus, if you do 2/3 times r, that is 6r. And then 9 times 1/9 is just 1, so you get r squared. So if you multiply through by whatever the common denominator would be, it'll get rid of the fractions. And then you can move everything to one side. So we could subtract that 9 and subtract the 9r. So you end up with, those cancel, -3 sorry, excuse me, plus r squared. And to solve, how do I solve that? I need to factor. It doesn't factor like normal. How do I factor that one, Chase? Okay, we will look for a greatest common factor here. What could I pull out of both of those? Oh, 1 and how many r's? I can pull 1 r out, right? So, what was that? Okay, so if I would have this, sorry, doing something wrong. Okay, so we would have 0. Why is it not letting me write? 10. Okay, all right, I want to go back. Okay, I think it's going right now. So I would have, and it might help, it might look a little better if we do this r squared minus 3r. So you're factoring out of r, and then you've got r minus 3 right here. And so you would set both of those equal to 0. R equals 0, and r minus 3 equals 0, so you get 0 and 3 as answers. Okay, you do need to check both of those answers. I think I'm just going to do it by hand for this one. It's not too bad. So you have 4 minus 0 plus the square root of 0 plus 1, which would give you square root of 4 plus square root of 1, which is 2 plus 1, which does equal 3. So 0 is an answer. And then if you plug in 3, square root of 4 minus 3 plus square root of 3 plus 1 is going to give you the square root of 1 plus the square root of 4, which is 1 plus 2, which is also 3. So in this case, both of them are the answers. Both will make this true. R equals 3 and R equals 0. So there's two possible answers. the factor that you pull out right here, that r, you have to set it equal to 0 also. Because if we plugged in a 0, like if we plugged in a 0, 0 squared minus 3 times 0, that would equal 0. So this is also a solution. So when you factor out a greatest common factor right here, you've got to set it equal to 0, and then you also set the other part equal to 0. Now there is a way to solve this that will make you lose an answer. If you had done this, if you'd moved that 3r over here, r squared equals 3r, and then divided both sides by r, you'd get r equals 3. You don't really want to do that. You don't want to find yourself dividing both sides by a variable, because it will cause you to lose an answer on that, so don't do it that way. I'm going to show you another option for this. If these fractions right here make you want to throw up whenever you see them, I'm going to show you another option where you don't have to end up with fractions. So let's go back to this point right here. So we've already got the answer, 0 and 3 is the answer. I'm going to show you another way. So you could go ahead and square both sides before you divide by the 6. If you do that, you got to square the negative 6 and square the square root of r plus 1. So you would have 36, negative 6 squared is 36, times the square root of r plus 1 squared is r plus 1. And then over here, if we square double square, we would have 36, and then negative 6 times negative 2 is positive 12. If you double it, you get 24r. And then square the last, so plus 4r squared. I don't know why I have parentheses there, you don't need them. So you get 36r plus 36 equals 36. Why is it quitting on me? 36 plus 24r plus 4r squared. So you could subtract your 36r and subtract your 36. So 0 would equal, this cancels, you'll get negative 12r plus 4r squared, or if you want, you can write that as 4r squared minus 12r. Andrew, what's our greatest common factor that we can pull out there? 4 and an r. So we'd factor out a 4r, so we'd have 4r times r minus 3. So this time we have to set 4r equal to 0 and r minus 3 equal to 0. So here you would divide by 4, which you still get 0, 4. And then here you would get r equals 3. Okay. I prefer that second way. I don't like getting into all the fractions, so I prefer to do it that way. But what you have to be really careful of, if you do it that way, when you square this side, you got to remember to square that 6 right there, and square the r plus 1, and make sure you put parentheses around it so that you distribute it. There. Okay, questions? Alright, we're not doing this right here. This is all your assignment tonight is going to be, yes. Okay. Your assignment tonight is on the same page that you guys had homework from last night. If you did it, I didn't put it on the thing. It's on page 255. And it's going to be number 15, 19 through 22, and 25 through 27. It's basically the ones you did not do last night. So if you did, if you did not do last night's homework, then you're just doing that whole section. And you can do them all together if you would like. Basically 15 through 27 is due tomorrow.
So you didn't check last night?
I didn't because I realized that I had put the assignment up in Math 1 instead of your class, so the video wasn't there. So in case you did not, were not able to do it, I think a lot of people did it anyway because they knew how to do the problems without watching the video, but I'm just going to give one more day on that since I had that wrong.
So the whole page down?
Yeah, so 15, if you didn't do any of it, you can just do 15 through 27 all together. That'll be fine. I will not think less of you for that